In this video, we'll prove that the ordering on the rationals has trichotomy. This is one of the statements that you would need to show is true if you were trying to establish that the rational numbers form an ordered field. So let's recall our definitions. We define a rational number m over n as the set of all fractions equivalent to the fraction m over n. And we require that in our definition here, the numerators can be integers, but the denominators are restricted to natural numbers. Then of course the set Q is the set of all rational numbers. Using these definitions, we can define equality of rational numbers as m over n is equal to p over q if and only if m times q is equal to n times p. So each rational number represents an infinitely large set of fractions, and according to our definition of equivalent fractions, if we define equality of rational numbers this way, then we exactly get what we would expect, that the infinitely large set of fractions that is denoted by m over n is equal to the infinitely large set of fractions that is denoted by p over q. So that's our definition of equality on the rational numbers. And our ordering on the rational numbers is defined as follows. If we have two rational numbers, f1 and f2, and we represent f1 as m over n and f2 as p over q, then the inequality f1 less than f2 means that m times q is equal to n times p. So again, we use the concept of cross multiplication to define the ordering on the rational numbers. So we're going to prove again that the order on the rational numbers has trichotomy. All right, so the goal here, if we're going to prove that the order on the rational numbers has trichotomy, is to take two rational numbers, a and b, let's say, and then show that exactly one of the following relationships hold. Either a is less than b, a is equal to b, or b is less than a. Okay, so let's do that. Let's let a and b be rational numbers, and let's represent a as m over n, and let's represent b as p over q. So we know in particular that m and p are integers, they can be positive or negative, and n and q are natural numbers. Now let's consider the integers m, q, and n, p. We know that the ordering on the integers has trichotomy. That's one of the axioms we use to define the integers. Okay, and since the order on the integers has trichotomy, we know that exactly one of the relations holds between these integers. So exactly one of these hold, either mq is less than np, or mq is equal to np, or np is less than mq. All right? And it just so happens that by definition of our ordering on q, which we gave just a minute ago, mq is less than np if and only if the rational number m over n is less than p over q. mq is equal to np according to our definition of equality on the rationals if and only if the rational number m over n is equal to p over q. And np is less than mq, again according to our definition of the order, if and only if p over q is less than m over n. So by considering the possible three relations between the integers mq and np, we see that they exactly correspond to one of three possible relations between our rational numbers m over n and p over q. All right, so in other words, exactly one of these following relations holds for our rational numbers a, b. Either a is less than b, a is equal to b, or b is less than a. That means that the order on the rationals has trichotomy. And that's it for this video. Thanks for listening.